Hello everyone, today let's study factorization, which is very important in solving the quadratic equations, the parabola, and many applications. Okay, so let's start with examples here. Example 1, x squared plus 5x. So you see the common factor here is x. So each term has x here, so x is the common factor. Then you put x in front, followed by a bracket. So x times what can go back x squared. So obviously x times x would be x squared. So write another x here. And x times what will be 5x, so it's 5 here. So basically, inside the bracket, you write the quotient of each term divided by the common factor. Next example, so 9x cubed plus 6x squared. You try your best to find the largest common factor. So here, for numbers 9 and 6, the largest common factor is 3. You write 3 here. For polynomials, x cubed and x squared, the largest common factor is x squared. So still write x squared here. So actually, the largest common factor is 3x squared. Then followed by a pair of brackets. 3x for the first term, because 3x squared times another 3x can go back to 9x cubed. And plus 2, because 3x squared times 2 can go back to 6x squared. Okay? Let's do another example. I actually give an example like 18x squared y cubed plus 27x y to the power 4. Okay. Now let here what would be the largest common factor? Let's see the not plus, is times. Oh yes, plus, not times. So the largest common factor between 18 and 27, which is 9. So make sure you're familiar with the timetable. So write 9 here. And for the polynomial part, so x squared and x here, which is x. And the common factor between y cubed and y to the power 4 is y cubed. And followed by a bracket. So 9x y cubed times what can go back to 18x squared y cubed here. So that'd be 2x. That's it. So 2x. Then plus. So 9x y cubed times what can go back 27x y to the power 4. So 9 times what equals 27, which is 3. And x is x, same x, you don't have to consider x. So y cubed times y equals y to the power 4. So that's the factorized form here. Next example, let's do 3 terms together. Say 36x to the power 4 y to the power 5 minus 48 x cubed y to the power 6 plus say 30 x to the power 5 y cubed. Okay, now let's find the largest common factor among 3 numbers, 36, 48, and 30. So we can see 6 is the largest common factor. So write 6, and for x term, the lowest power for x term would be the lowest common factor for x term. So here is x cubed. So write x cubed. For y term, y to the power 5, y to the power 6, y to the power 3. So y to the power 3 is the common factor here. Okay, so the common factor times what equals the first term, 36x to the power 4 y 5, which is 6x y squared. The minus 6 times what equals minus 48, so the minus 8. Then x cubed times 1, x cubed you don't have it right, so y cubed times y cubed equals y, go back y6. Then plus 5 x cubed times what equals x to the power 5, which is x squared. And the y cubed times 1 equals y cubed, which is 1, you don't have right. So that's it. That's the factorized form for this question. Next. Before we go to the next section, we'll do some examples for polynomials here. Okay. The pure polynomials without any number here. So say a to the power 4, b to the power 3, y to the power 5, and minus a to the power 3, c, and y to the power 2, then plus a squared, c squared, y to the power 3. So it appears to be complicated. So no number here, you don't have to consider number. For polynomials a, so be lowest power for a is a squared, so a squared here. No, b is not common factor, it's only the first term includes b. And the c is not as well, because only the last two terms include c. So we don't have to consider b or c. We have to consider y, y to the power 5, y to the power 2, y to the power 3, then b, y to the power 2, which is the lowest, the largest common factor here. The first term becomes a squared, b cubed, y cubed, then minus ac, then plus c squared y. So that's it. It's simple enough. Okay. Okay, let's have some questions for difference of two squares. So there's a formula here called difference two squares. Difference means subtraction, and from two squares, so a squared, b squared, which equals a plus b times a minus b. Remember, a, b, both a, b could be numbers, polynomials, or expressions. It could be expressions like x plus 1, x plus 2, 2x minus 1, anything. Okay? Now, let me give you an example here. Let's do x squared minus y squared. So obviously here, x is the a in the formula. So that equals x plus y times x minus y. Okay. If include numbers, so let's say x squared minus 9. So at first sight, you see this one doesn't satisfy the formula, because the formula is something squared minus something squared, but 9 is just a number. So we rewrite the question as x squared minus 3 squared. Okay. Remember here, a and b doesn't include the sign here. You don't need a sign like plus minus. They are always positive here. So that becomes a is x, b is 3. So x plus 3 times x minus 3. Another example. So x squared minus 16 equals x squared minus 4 squared equals x plus 4 times x minus 4. Okay? Next, let's say 4x squared minus say 81 here. So equals what? Equals 4x squared minus 9 squared. So up to now, many students will write 4x minus 9 times 4x plus 9. Alright? So according to my experience, many students will write that way. But it's wrong. Because 4x times 4x is 4x whole thing squared doesn't equal 4x squared. So you rewrite here 2x bracket squared. So the whole thing squared equals 4x squared. Then minus 9 squared. So here a is 2x, 9 is b. So that becomes 2x plus 9 times 2x minus 9. It doesn't matter you write a minus 9 in front or plus 9 in front. As long as it's 1 minus 1 plus, that's fine. Okay. Now, let's do one example. A and b, one of a and b is an expression here. So, be a squared minus b plus 1 squared. This one also can also fits the formula, because that's something squared take away another thing squared. So a is still a here, a plus b plus 1. For b plus 1, usually you have to put a bracket, but you don't have to in this case, because the before b plus 1 is plus. You can expand the bracket directly. Then times a, take away, you do need a bracket here, b plus 1 minus b plus 1, then close the bracket. But you have to expand this bracket. That becomes a plus b plus 1 times a, take away b, take away 1. Because when you expand the bracket, the minus sign then becomes minus here. Okay? Next, say 4a squared minus 2b plus 2 squared. Remember the first term is 4a squared. You always change to 2a, the whole thing squared, minus 2b plus 2 squared. That still fits the formula because one thing squared minus the other thing squared becomes 2a plus 2b plus 2 times 2a minus bracket 2b plus 2 close bracket, expand this bracket. So 2a plus 2b plus 2 times 2a minus 2b minus 2. Okay? But here you find still the common factor in both brackets. For the first one is 2, you put that in front, becomes a plus b plus 1. Okay? The next one, when you times the number and the number in the middle, you have to write the sign for times. So times 2a minus b minus 1. So these 2 times these 2 is 4. A plus b plus 1 times a minus b minus 1. Okay? Next example is, so 8x squared minus 98 y squared. Well, many students look at first sight, they thought this question didn't fit the formula. Yes, it doesn't fit in the current form, but when you put the common factor here in front, which is 2 here, so it becomes 2, 8x squared minus 49 y squared. Now you find what's inside the bracket will fit the formula. Okay? So that equals 2 bracket, oh sorry, not 8, is 4. So that'll be 2x squared minus 7y then squared. That's it. Then 2 becomes a is 2x, b is 7y. So 2x plus 7y times 2x minus 7y. Okay? So we finally found that does use difference 2 squares. Next, let's move to perfect square formula. The formula is a squared plus 2ab plus b squared equals a plus b squared. If the middle term is a minus here, then it becomes minus b. Remember, the last term must be positive, because the first and the last term refers to something squared, which must be a non-negative number. And similarly, a and b could be numbers, pronumerals, or expressions. Could be any expression. Could be a could be x plus 1, x plus 2, x plus 3, or 2x plus 1, or anything. Okay. Let's give an example here. The x squared minus 4x plus 4. Okay. If that fitted the perfect square formula, then x squared, so x would be a in the formula, and then 4. What's 4? 4 should be something squared. The rewrite is 2 squared, so 2 should be b here. So b is 2. Then the middle term should be either a positive 2ab or negative 2b. So a is x, b is 2. Then 2ab equals 4x. So here is negative 4x. The only difference here is a sign. So that means becomes x minus 2 squared. Because a minus b squared. If that's positive, then becomes positive. Okay? Next, y squared minus 6y plus 9. So 9 is 3 squared. We do plus 6y. So that equals a is y and 3 is b then squared. But we have to double check 2ab. So 2 times y times 3 equals this 6y. So that's right. That perfectly fits the formula. Next, we'll give example which is a little bit different different here. Right, 4y squared plus, I'll give you the last term first. 9x squared. The middle term is 12xy. Okay, so that becomes 2y squared. Right. 2y squared plus 12xy plus 3x then squared. Okay, so let's double check if that fits the formula. That would be 2y plus 3x squared. So 2y is A, 3x is B, then 2ab equals 2 times 2y times 3x exactly equals 12xy. That means our factorization is right. Next, 2x squared minus something. We'll still write the last term first. Let's say 8y squared, and it's 2y xy, and the middle term would be 8xy. Okay, now first you always check if three terms have common factor, but you do find a common factor here, which is 2, right? 2x squared minus 4xy plus 4y squared. Okay, so that should fit the perfect square formula. So copy these two. So if that fitted, that would be x minus 2y squared. Remember, it's not 4y, it's 2y, because the square root of the whole thing is 2y. And that's A, that's B, then 2ab would equal 4xy. So that here gives minus, then minus. So that's the answer for that one. Okay. Now let's discuss the more general case for the factorization. In most cases, you won't find the three terms which fit the perfect square formula, or two terms fitting the difference two squares. Usually you can find three terms, square term, the x term, the constant term, but they don't fit a perfect square formula. But you can factorize that probably by cross method here. Now, let's do the cross method by using examples here. So let's see example 1, x squared plus 5x plus 6. So how can factorize this? Now, remember, implicitly the number before x squared is just a 1. Okay? So you factorize this 1 can only be 1 times 1. You write in the same column. Then you factorize the 6. Factorize 6, there might be two ways. The 1 is 1 times 6, okay? But then you cross times. So 1 times 6, you diagonally times 1, 6 and 1, 1. Then add them together. So 1 times 6 plus 1 times 1, which equals 7. Doesn't equal 5. So that means this combination for 1, 6 is not right. Let's choose the other way. The left still be 1 times 1, but the right could be 2 and 3. So you do 1 times 3 plus 1 times 2. 1 times 3 plus 1 times 2, which exactly equals 5. That means we get the right combination. Okay? And finally, we write the factorization as, so this ones means the number before x. So write bracket first. So 1 means 1x, you don't have to write 1, you write x. These two we choose the same row, not column. So x, that's positive 2, means x plus 2, then times x plus 3. So that's the factorization for question 1 by using the cross method. Okay. Now we'll do another example for x squared minus 5x minus 6. So we'll do the same thing for number before x squared is 1, so do 1 times 1. But here, you factorize negative 6, okay? It's negative 6, not positive 6. That means one of them, add of them must be a negative number. So negative 6, let's try negative 2 and 3. But when we cross times and add, so 1 times 3 plus 1 times negative 2, 1 times 3 plus 1 times negative 2, which doesn't equal negative 5. The number before x is negative 5. Okay, so that one is not right. We choose the other way, 1 times 1, that be negative 1 and 6. Let's try this way. So 1 times 6 plus 1 times negative 1. So 1 times 6 plus 1 times negative 1, just minus 1 times 1, which equals positive 5. It doesn't equal negative 5, but the only difference here is the sign, right? So when you find that the only difference here is sign, that means you choose the wrong, you give the sign to the wrong number. That means it should be 1 times 1 times positive 1, negative 6. Let's double check that. So 1 times negative 6 plus 1 times 1, which exactly equals negative 5. Okay, so that means this one is the right combination. And finally, we choose the same row. So 1x be x plus 1 times x here minus 6. Okay, so that's the solution for that question 2. Now we do solutions for the last one. I rewrite copy here. So x squared minus 9x plus 20. Well, in this case, you see the constant number here is positive, but the number before x is negative. So that means when you factorize 20, there must be 2 negative numbers here. So 1 times 1 for this one. And 2 negative numbers. Now this time I just give the right combination. Must be negative 4 and negative 5. Because when you cross times, add them together, it's negative 5 plus negative 4, which is exactly negative 9. So the right solution for that is we choose the same row, be x minus 4 times x minus 5. Okay? Let's go to the next section. Here, you might also meet the type that all 3 terms have a common factor here. For example, question, the first example, here they have the common factor 2, so you put 2 in front. So 2x squared plus 6x plus 8. Okay, now you've just factorized what's inside the bracket by the cross method. So 1 times 1 for x squared term, and 2 and 4 for 8. Then you 1 times 4 plus 1 times 2 equals this 6. The correct combination. Then you choose the same row, so that becomes x plus 2 times x plus 4. And finally, you put the 2 in the very front here. So the final answer is 2x plus 2 times x plus 4. And similarly, for this question, it will be 2x squared minus 7x plus 12. Okay? So that would be 1 times 1 for x squared term. So this number is positive, this number is negative. There must be two negative numbers. We choose negative 3 and negative 4. Cross times. So negative 4 minus negative 3 equals negative 7. The right combination. To copy the 2 here, that becomes x minus 3, x minus 4. Okay? Next, when we have fractions, here we always put the fraction as the common factor. So whereas the half x squared plus what? So 8 divided by a half, that means 8 times 2. So it'll be 16x plus what? Plus 48. Okay? In this case, we have 1, 1, 12, and 4 cross times. So that becomes a half x plus 12 times x plus 4. Okay? And for that one, so put 1/3 in the very front, be x squared minus what? 8x. Then plus what? 24. Because when you expand bracket, you can go back to here. We factorize that, so 1, 1. Negative, positive must be two negative numbers. Oh, I didn't give a good example. It should have been 8. Let's try 5, okay? Then that becomes 15. Now it works. So it'll be negative 3, negative 5. So 1 times negative 5 plus 1 times negative 3 is negative 8. Right combination. So 1/3 x minus 3 times x minus 5. Okay. Next, the next type is a little bit complicated because the number before x squared is not 1. It's 2. But as I said previously, we have to factorize the number before x first. So here is 2. The only factorization for 2 is just a 1 and 2. Okay? And similarly, we factorize negative 18. So one of the number factors must be a negative number. Okay? Let's try. Actually try the factorization for negative 18. Could be negative 3 and 6. Okay? We put negative 3 here, 6 here, cross times, it would be that. So 1 times 6 minus 2 times 3 equals 0, which doesn't equal 5 here. So obviously not right. But what in the case the number before x squared is not 1, you may flip those two numbers to try another combination. So 1, 2, 3, 6 minus 3 here. You cross times, that equals what? Equals 9, which doesn't equal 5. So that means you can't choose 3, negative 3, 6, or whatever the negative. whatever the negative sign is, because you didn't find negative 5. If you find negative 5, then you just give the negative sign to the other number. So let's try the other one. So we're still 1, 2, which is the unique unique factorization for 2. 18, it could be 2 and 9. One of them is a negative. Let's try here. So negative 2. And you cross times. Oh, that becomes 9 minus 4, which is 5. Right? We got it as 5. So the right combination becomes, the number before x is 1, so x minus 2. But pay attention to the bottom here. The number before x is not 1 anymore, so it's 2x plus 9. Okay? Now let's do the second question. The factorization for 3 is just a 1 and 3. For 4, let's try, because this positive, this negative both must be negative numbers. Let's try negative 4 and negative 1. When you cross times, that equals negative 13, which doesn't equal negative 8. If we flip that, be negative 1, negative 4, that equals negative 7, doesn't equals 8. So 1 and 4 must not be chosen. So 1, 3 again, there must be negative 2 and negative 2. Double check. So 3 times negative 2 plus 1 times negative 2, exactly negative 8. Now we choose the same row. So be x minus 2, 3x minus 2. Okay. Now we do the last one. Now we'll copy the question here. And 6x squared minus 11x plus 4. Okay. Now, for the number before x here is 6. 6 doesn't have a unique factorization. It could be 1, 6 or 2, 3. Okay? So you may consider two cases, 1 and 6 or 2 and 3. So let's try 1 and 6. And the 4 could be 1 and 4. But it's a negative number in the middle, so that must both be negative here. So when you cross times, that equals negative 10. You see, doesn't equal negative 11, so not right. 1, 6 again, be negative 2, negative 2. So that equals negative 14. We'll cross times and add negative 14. It doesn't equal negative 11. That means 1 and 6 never works. So there must be 2 and 3. So negative 1, negative 4 here. So that equals, exactly equals negative 11. Okay, so that means we got the right combination, be 2x minus 1 times 3x minus 4. Okay.